Hello students, in this video we learn about conversion of moving coil galvanometer to voltmeter. So we already studied about moving coil galvanometer. It is a sensitive device, sensitive to current only. So now here we will discuss how we will convert this moving coil galvanometer to a voltmeter. Look at the diagram. This is a typical galvanometer, moving coil galvanometer, and this I indicates the circuit current. I mean the current from which we want to measure the voltage drop. Okay, it is the application circuit. Here we have connected the voltage. Yeah, now you can see here. Okay, this is external circuit. Okay, this is the circuit element at which we want to measure the potential drop. And here if you observe galvanometer, we have connected a series resistance R to a galvanometer. It is connected in series, and it is made very large. R is very large resistor. Okay, making R very large implies a large amount of potential drop here itself, leaving moving coil galvanometer as a safe thing. And one more thing, we connect this moving coil galvanometer parallel to the circuit, parallel across the element at which we want to measure potential difference. So here you can see this is the incoming current circuit, and this current should pass through this. Here a current is dividing here. Ig is flowing through the galvanometer. As the resistance R is very large, a small amount of current flows through this, leaving most of the current to pass through this element. And here, as this circuit element is in parallel with the moving coil galvanometer circuit, potential drop across these two are same. So this is the principle we use here. So V, the potential drop at circuit V is equals to, here the potential drop at circuit element is equals to whole potential drop at the moving coil galvanometer. The potential drop at moving coil galvanometer is measured as Ig, current into resistance. R is very large resistance, and moving coil galvanometer also contains some resistance G. So we can write it as Ig into R plus G. So here we wrote V equal to Ig into R plus G. This is the principle how we can measure the resistance that should be connected in series. So from this, here you see we have studied about moving coil galvanometer, and we know that moving coil galvanometer is sensitive to current only. We have seen that the theta is proportional to I there. Theta means the angle of deflection is proportional to I, incoming current only. How it can measure voltage here? So this reason is very simple. Here it is still measures current only. Okay, it still measures current only, but we give the manufacturer give gradations in voltage, and the incoming current or the current Ig is directly proportional to voltage, that we can see here. So V is the voltage across the circuit element, and Ig into R plus G is the voltage across the galvanometer. And here now we want Ig. Ig means galvanometer current. So Ig means V by R plus G. V by R plus G. You can see here R is large resistance which is constant. G is galvanometer resistance which is also constant. So these two are constant. Only variable is voltage. Voltage across circuit element. So this voltage across circuit element changes, then Ig also changes. So if you increase the voltage, then Ig also increases. If you decrease the voltage, then Ig also decreases, because R plus G is a constant. So from this we can say that this incoming current, galvanometer current, is directly proportional to voltage across the circuit element. Based on this principle, this incoming current is still sensitive to voltage across the circuit element. We design moving coil galvanometer based on this. So now look at a small example problem so that you can understand. Now here we have a problem. This problem is just like how the manufacturer implements this logic. So determine the series resistance required to convert a galvanometer of specifications 1 milliamp and 20 ohms into a voltmeter of range 0 to 10 volts. So in this problem, he has given specifications of galvanometer, and he wants to convert this moving coil galvanometer to a voltmeter of range 0 to 10 volts. So here the logic is simple. We have seen in the diagram that a moving coil galvanometer can be converted into voltmeter by connecting a resistance in series. Now first we will calculate how much resistance we should connect. So based on the specifications, we connect. From the data, we can write current through galvanometer is 1 milliamp. That means 1 into 10 power minus 3 amps. G, galvanometer resistance is 20 ohms that we have taken. And voltmeter range is maximum 10 volts. 0 to 10 volts, we take the maximum because this IG galvanometer maximum permissible current is 1 milliamp. So maximum voltage is 10 volts. We take this formula. So here V equal to Ig into R plus G. Now we want R. So what we can write, V by G equal to R plus G, and you take G to that side, then we will get V by Ig minus Rg. Substituting all the quantities, we will get this becomes 10 power 4. That means 10,000 minus 20. 9,980 ohms. This is the resistance that should be connected in series to make the galvanometer as a voltmeter. So in this problem, if you connect in this resistor, then it becomes a galvanometer which is sensitive to voltage. So here the logic of the manufacturers like this. Simply he designs this galvanometer and gradations are indicated as volts, 0 volt, 5 volt and maximum 10 volts. Our galvanometer sensitivity varies from 0 to 1 milliamps maximum. Okay, so here the moment it starts rotate, the moment it starts deflecting, it deflects according to the current Ig galvanometer current, but this galvanometer current Ig is directly proportional to the voltage. Ig is directly proportional to voltage. So this is in accordance with that. When the deflection starts moving in accordance with the current, same reasonable proportionate of voltage is shown here. So in this way it indicates the voltage, though it is sensitive to current. Thank you.